21, 15, 21. Okay, number 430, 1, 2, what else? 5, 6, 3, 10, 15, 75, 1, 3, 25, 5. Nope.
No.
15. You start. I usually start dividing by 2 and do it from that. Yeah.
I have a way to.
Okay, so the greatest common factor that all 3 share. 15. No, greatest. Okay, so our greatest common factor is 15. Number 1, 39 and 6. So we're going to find the greatest common factor between both. Number 2, 24 and 28. 4, is there anything bigger? 12 doesn't go into 28. Not 6, it's just 4. Number 3. Eliminate the variables for a second. 39 and 30. 3, right? So if I just stopped there, it would be 3. But now let's look back at those variables. Is there anything that's in common with the variables? Just b, right? So essentially what I'm doing is I'm factoring anything that they have in common, but with the values, so numerical values, I have to make sure it's the biggest one I can say. So here, 3b times 13 is going to get me back to where I was, right? 3b times 10u is going to get me back to where I was. Does that make sense where I'm getting these values from? Okay, let's look at number 6 together. I'm going to have you guys do 4 and 5 on your own. But number 6, 144, 48, and 96. It's not 12. 8. Not 8. Not 24. It is not 35. It's 48. Okay, it is 48. 48 times 3, 48 times 1, 48 times 2. Okay, now, let's look at our variables. Can I pull an x?
Yeah.
Can I pull more than one x?
No.
Yes.
There's 3, 2, and 2. What's the max that I can pull from everything? 2. So x squared. Can I pull a y from everything? No, not at the end. So my greatest common factor of those 3 is 48x squared. Well, the y is not on 96x squared, so let's check, right? If I have 48x squared and I multiply it by 3xy, will I get back here? Yeah. If I have 48x squared and I multiply it by 2y, will I get back here? Okay. If I have 48x squared, what do I have to multiply it by to get back here? 2. This was just 1 y, sorry. 2. So you see the y is not in the last one, so I can't use it as a GCF because it's not included in everything. Okay, you guys find me the GCF on 4 and 5. Come back with me. 35mn squared, 21m squared n. 7mn. That's the max that you can pull. Max, put that one down, please. Thank you. 30y cubed, 20y squared. 10y squared. Because you have 3 here and 2 here, so you can't pull more than you have from each one. You can only pull 2, which means you have 1 left over on the other one. Okay, that is just finding the GCF. We're going to start factoring trinomials. And when you're factoring, either it's a binomial or trinomial, whatever the polynomial will be, the first thing you always want to check is if you can factor out a GCF. Okay? So I'm not trying to solve anything here. Kind of like if you had a fraction, if I had 20 over 24, would I leave it like that? No, I'm simplifying. What I'm doing is I am like reverse multiplying. So I'm factoring, and I'm going to find 2 binomials. Right now, all I'm finding is the GCF if there is one, because that's your first step. So if I look at 15x squared, 20x, and negative 30, the first thing, can I pull a variable from that? 30 is negative, and 30 doesn't have a variable. There is not a variable on everything to pull. Right? X squared x and no x at all. So you can't pull a variable. So you look at the coefficients, 15, 20, and 30. What's their GCF? 5. So what I'm going to do is I'm going to divide all of this by 5. And since I'm factoring it, I'm not just going to write what's left. I have to write that the 5 is out front now. You're undoing distributive properties. And then what would be left? Well, what's 15x squared divided by 5? 3x squared. What's 20x divided by 5? And what's negative 30 divided by 5? Negative 6. So that is the answer for just factoring out the GCF. Okay. So let's look at number 8. What is the variable that can get pulled? K. There's a k cubed, a k squared, a k. You only have 1 in the last one, so you can only pull 1 from everything. So that's where I'm going to start, is with k. But I also need to look at, right, it's the lowest one that's involved. 5, 5, and 15. 5. So I'm going to not just make this k, I'm going to put 5k. So now what's going to be out in front? 5k. And then left inside, k squared plus k minus 3. And that's factoring out the GCF. Why don't you guys try 9 and 10 really quick? And then I want to talk about 2 more scenarios. Number 9, what'd you get? 2x, x squared. Very good. What'd you get for number 10? 12. Very good. Okay. So, special cases. Number 11. What do they share? P. Now, here's something else. It's the only one on the entire, well, no, number 13 too. Looking at number 13 and number 11, what do they have in common besides the fact that it's 2 terms? The leading term is negative. That's what I was looking for. The leading term is negative. You never want your leading term to be negative. So, in a scenario like 11 or 13, the first thing that you're going to factor out is a negative. So for number 11, we're going to factor out negative p, not just p, negative p. So then you need to have everything there, because if I went through and I multiplied everything back, it has to be exactly the way it started. So negative p, if I factor that out, what's left in? P minus 7. Well, you factored one out. If I factored out the negative on number 13, I factor out a negative, what does 16 and 24 have in common? 8. Can I factor out any variables? Y. So negative 8y, what would be left in?
No, 2y.
2y
Minus 3.
minus 3. Very good. Okay, last piece before we move on, number 14. It doesn't have a GCF. It doesn't have one. Realistically, if it didn't have a GCF, we would look for the next way to factor it. If you cannot factor it at all, it is prime. If there is no GCF, if you cannot factor it, we call it prime. Kind of like if you have a prime number, you can't factor it. It's just one in itself. Because the only thing that I can factor from this is 1, right? But I can factor 1 for anything. Everybody go with GCF? All right, let's move forward. We're just continuing with factoring. So, what is the polynomial that's represented inside my area model here? Now, x squared plus 9x plus 20. X squared plus 9x, x squared plus 9x plus 20. We know this model. We multiplied polynomials, we divided polynomials, all using this model. We're going to factor using the same thing. Now, every time that we've come back to this model, something different has been missing. In this case, the outside's missing, but all of the outside. Based on what you know, what are my top two values? X plus 4. What are my side values? X plus 5. So those are the factors. So if I have x squared plus 9x plus 20, I can factor it and rewrite it as x plus 4 times x plus 5. So we're just reversing what we did previously. Now the thing is, where it becomes more difficult, because that was pretty easy, right? You need to figure out how to build your model. So that being said, it would have been really easy for me to input x squared and 20. But I'm going to have to do a little bit of work to find 5 and 4. Because 5 and 4 is a way to add to make 9, but is that the only thing that you can add to make 9? No. So this 20 plays a huge role, and so does the x squared, because they have to work together in order to get those factors out. So first thing we're going to talk about, standard form. This is ax squared plus bx plus c. Remember ax plus by equals c? You have standard form, whether it's a quadratic or a linear. You're looking at a, b, and c. So write that in. Ax squared plus bx plus c. So when I look at my example here, x squared plus 6x plus 5, and I relate back to the initial picture, I knew that it was really easy for me to place a and c. So if I place a, which is 1, right, but let's put the whole term, x squared, and I place c, I've got a starting point in order to find my factors. Because this number depends, right? I have this nice little T-chart out here because what we're going to do is we're going to look at factors of 5. The reason I'm looking at factors of 5 is because I need to find out what's here and what's here, right? What are my factors of 5? 5 and 1. We're starting off simple. It's prime. So the only things that can go in those spots are 5x and 1x. Because this has to be 5 and 1. What's special about 1x and 5x though? It combines to make 6x. So what you're looking for, you're technically multiplying here, and we'll talk about that in a little bit, is you're looking for factors of a times c, or 5, that have a sum of b. Well, what's x, where are these values? So where did that x come from? I'm trying to find b. See, because in our initial model, we had those x's already given. Okay, let's try another one. We're going to build the steps as we go. I will tell you the first step is to factor out the GCF if any. You also want to factor out a negative if A is negative. So those are things that we talked about on that previous page. If A is negative, you got to factor it out. If there's a GCF, you want to factor it out. Those are the first 2 steps. Now let's build the steps moving on from there. Looking at number 1, what is my, I'll rewrite this in there. What's my A value? The coefficient. 1. My A value is 1. What's my C value? Negative 14. So what we're going to do is we're going to multiply those. So in this case, it's really easy when A is 1. Negative 14. And I need factors of negative 14 that have a sum of negative 5. Say again? Negative 7 and 2. Everybody agree with that? Okay. If you are not sure where to start, I can always start with ignoring all of the negatives, right? 14 and 1, 7 and 2. It does not have any more factors, does it? 14 and 1, 7 and 2. Now that I've got all of my factors, if my sum is negative, that means that my larger value has to be the negative value. You see what I'm saying? Now, which one will give you negative 5? It's here. Those factors are your diagonals. So negative 7, but it's not just negative 7. It's negative 7x and positive 2x. So you found your factors. What are these 2 values? X squared and negative 14. Those ones are easy to place because it's just your ax squared and your c. Yep. X minus 7 times x plus 2. So your answer is x minus 7 times x plus 2. Okay, look at number 3. What's your A value? 4. What's your C value? 5. Was there any GCF there? No, you've got 4, negative 12, and 5. 5 is fine, so you're out of line. Okay, that doesn't make it prime because we can factor it. It's only prime if it's unfactorable. Okay, A times C, 20. I need factors of 20 that have a sum of negative 12. So I'm going to ignore the negatives for a minute. 20, 20 and 1, 10 and 2, 5 and 4. Anything else? Okay, now, in what scenario would my product be positive but my sum be negative? They have to both be negative. So now we'll do this. Which combination is going to give me negative 12? 10 and 2. So we would take those and throw them in the diagonal. So negative 10x and negative 2x.
Well,
Yes.
Whenever we do 4 times 1, we did negatives after that.
Yes, because your sum is negative. Your product is positive because this number plays a huge role. Okay? So now from there, I've got those. Let's fill in the other diagonals. We've got 4x squared. And what else? And 5. When you are factoring and you're dealing with a lot of negatives, the goal is to try to make the values for x squared positive. So can I pull positive values? I know that there's an x on each one, right? What else do I know? 2x and 2x. That would work. Now, if I took 2x, how would I get negative 10x from that? Negative 5. How would I get negative 2x over here? Negative 1. So my answer now is 2x minus 1 times 2x minus 5. Does not matter which order you put them in. I could have put 2x minus 5 first. Let's try another one, and then we'll build our steps. Number 2. I'm numbered weird. 2x squared plus 14x plus 24. Anything stand out there? Divide everything by 2. Factor out GCF. So now 2 times x squared plus 7x plus 12. So we're doing it for each one, but was there a GCF for number 1? And was there a GCF for number 3? So I'm checking, but only if there is one do I factor it out. Okay, so now my A value is positive, wonderful. I've got this 2 out in front. Be very mindful, just like when we did simplifying radicals, if you pulled that 2 out at the beginning, don't forget it at the end. So this 2 is going to be out in the front in my answer. It doesn't just disappear. You can't just lose numbers. Okay? Say it again? No, the goal is at the end that you can redistribute out and get back to the same answer, but we're just going to leave it like that. Okay, so now that I've factored out the GCF, my A value is no longer 2, it's 1. What's my C? 12. 12 and 1, 12. Factors of 12 that have a sum of what? 7. So 12 and 1, 6 and 2, 4 and 3. Which one of those will work? 4 and 3. So go ahead and throw those in your diagonal. 4x, 3x.
But does it matter the squares?
Nope, as long as you pick those diagonals. These two can swap as long as the top right and bottom left are your factors. Okay, what goes in the top left? X squared. What goes in the bottom right? 12. So what can give me x squared and 3x? X plus 4, x plus 3. No worries. X plus 4, x plus 3. Okay, why don't you guys do number 4 on your own? What y'all get for number 4? 8 times x plus 5, x minus 4. Very good. Okay, you do have homework. There is another page there, those are extra practice problems. Homework, there are 10 problems. It spans over 2 pages, but it's just 10 problems. All 10 are your homework, okay? That's extra. Okay?